Unit 5, Relationships in Triangles. We're on Lesson 5.3, Medians and Altitudes in Triangles. Objectives. Identify special segments in triangles and understand theorems about them. We're going to be reviewing, once we get these last two, the 4 special segments in triangles that we've been dealing with, and you need to be able to recognize them and know their properties. Find and use the point of concurrency of the medians of the triangle and solve problems, improve relationships in triangles, and find the point of concurrency of the altitudes of a triangle. Terminology, medians of a triangle. What is a median of a triangle? That's important that it's of a triangle. Medians also used in statistics as the middle number when the data is ranged in order. A median is a segment joining a vertex to the midpoint of the opposite side. Centroid, when you have all 3 medians in a triangle, up in that example we only had 1, but the 3 medians of a triangle intersect at a point called the centroid, which is point P there in the diagram. List all the medians. There's one, that's segment AE. There's another one, segment BF. And segment CD. There's special properties about the medians. Length of segment AP is equal to twice the length of segment PE. So the median is cut into 2 parts. One is longer than the other. The part that's longer is twice as big as the smallest part. The smallest part is half as big as the longer part of the median. Length of segment AP is 2/3 of the whole thing, and length of segment PE is 1/3 of the entire length of the median. Centroid example 1, if P is a centroid of triangle JKL, there's point P, and it's made from medians, so we know all of that information, just like in the diagram down to the right. Let's see, first piece of information they give us is length of segment JK is 22. So that entire side is 22, but if M's the midpoint, then we can divide it in half, and each of those pieces is 11. Next piece of information they give us is length of segment KN is 13. So if we're looking for the length of segment NL, it's going to be the exact same thing. So that is also 13. Length of segment KL, well, that's that entire side. So we could either add 13 and 13 or double 13. We get 26. Next piece of information they give us is length of segment OL is 18. Mark it, which means length of segment JO is 18. And length of segment JL is going to be those two combined, or 36. Example number 2. If Z is a centroid of triangle TUV, so it's made up of medians, so we know all this information. Length of segment TZ, they give us the 60. Okay, so now we're looking for the lengths inside the triangle, and that's the longer part, which means if we want to get the shorter part, we are going to have to divide that by 2, and we get 30. So there's length of segment ZY. Next piece of information they give us is length of segment XZ is 28. That is the shorter part of that median, the median segment VX. So if we double that, we're going to get 56, which is the length of segment VZ. They also give us length of segment WZ is 25. That is the shorter part of that median, so we can double it to get the longer part. Let's see what else they want. Length of segment TY, that's that entire median, and we have the 2 pieces, so add them up and we get 90. Length of segment XV, that is the length of that entire median, Add up the two lengths, segment addition postulate, we get 84. Number 3, G is a centroid of triangle ACE, so it's made up of medians, and we know all that information. They give us length of segment AG is 8. That is the longer part of median AD, so we can cut that in half, and we get length of segment GD is 4. They want the length of segment AD. That is that entire median. Segment addition postulate. Let's add them together. We get 12. Length of segment CG. Well, let's see. They give us length of segment GF is 7. That's a shorter part. So to get length of segment CG, we have to double it. We get 14. They give us length of segment BG is 5. That's the shorter part of that median, so if we double it, we get the longer part, segment GE. Length of that is 10. That whole median is going to be 15. Centroid example number 4. If X is a centroid of triangle RST, which means those segments are medians, we know all that information. If the length of segment TU, that entire median is 27, the easiest thing to get to is the shorter side. So if we divide that by 3, we get 9. That's the shorter end. Double it, we get the longer part. If we were to add those together, yes, we get 27. Next one, length of segment SW, right there is 18, divided in thirds. Smaller part is 6, length of segment XW is 6, double it, and we get the longer end. Add them together. Segment addition postulate, we do get 18. Yes. Length of segment RV, let's go camping, is 21. Divide it in thirds. And Rx is 7. Ooh, but that's not what they're asking us for. They want the other one. Oh, no big deal. Double it. And we get 14. Centroid, example number 5. If J is a centroid of triangle DEF, then we know it's made from medians and all that information. Let's see what they give us. Length of segment DH, that's the entire median, is 51. Let's get the shorter part. If we divide 51 by 3, we get 17. That's the shorter end. Double it, we get the longer part, 34. So length of segment DJ is 34, length of segment JH is 17. Don't always do them in order. Makes more sense the other way. Length of segment GF is 60. There's another entire median. Easiest part, get the shorter end. So divided by 3, we get 20 for the length of segment GJ. If we double that, we get the length of segment JF, which is 40. Segment addition postulate, just check. 20 plus 40, 60. Yes. Length of segment EI is 57. That's that entire median. Easiest part, of course, is to get the shorter side, or shorter part, excuse me. Divide by 3, we get 19, and we just double it to get the longer end. Wrap up. Properties of centroid of a triangle found inside the triangle. Always, we did find that or discover that in our Desmos activity. It is found at the intersection point of 3 medians of a triangle, and the centroid divides each median into 2 parts, 2 segments, in a ratio 2:1. That is the end of part 1.